And as you notice on this unit review, it's going to be a little more spaced out tomorrow, a little bit. But as far as length goes, we're going to be looking at the same thing tomorrow that we've got going today on this, which basically is, you know, the same stuff we've been doing for quite a long time now. Reminders, the assistance that you have had, okay, the help sheet, that's still available to use on the unit test tomorrow. So, when I start taking a look here, a couple of things I think about. One, that Mr. Harty's nice. We have parentheses on here. Okay, actually I have to thank Mrs. Abruzzo for redoing that because I wasn't going to. But when I look at this, it helps remind me, hey, I can't cancel these 4s or these x's right away because these guys are bonded. Okay, that plus bonds them, but the parentheses just remind me of that. But it doesn't mean I can't do anything. So if I look at that denominator for a second, do those two terms have anything in common? Yeah, what? Okay, 4 and an x. Good call. So, once I do that, I say, okay, if I needed to multiply this to get that back, x squared. Because again, I've got 1, I'm trying to get up to 3. We're going that route. And then 4 times what will get me to 12? 3. Okay. So once I get that taken care of, now I can actually go back and look and say, okay, now I've got a piece that's not in the parentheses here. Yeah, at this point I can say, okay, those 4s aren't in there. I can kind of whack those. And then I use my exponent rules to deal with the x's that are there still. So 2 minus 1 is 1. Bigger exponents up top, so I can put x, or I can put x to the first. And since there's no other parentheses to cancel out with, I leave that. So that's as far as we're getting on that one. We're done. And we've talked about this before too. There are some differences as we go through these on how we do this. Now, notice again throughout this entire section, no mention of a common denominator because we don't need one when we're multiplying and dividing. Okay? So here, again, I know it's going to seem strange at first, but we've talked about when there's no pluses and minuses. Let me stress that again. When there's no plus or minus, I can multiply straight across with these. It actually is going to make it easier to look at one fraction. So I multiply 15 times 3 times 10. Yep, 450. And then I look and I'm like, okay, there's no other x's up here. There's no other y's up here. And if you did the y's first, it's not a big deal. Then I do the same thing down below. 6 times 125 is 150. And again, I have some x's and some y's, but not where I can actually put them together at all. Yeah, now as far as my exponents go, when I go to make my last fraction, exactly, I'm still going to subtract my exponents, and I'll come back to the number part in a minute. 8 minus 4 is 4, bigger exponents up top. So I put my x to the 4th there. 6 minus 2 is also 4, but it's going to go on the bottom because of the larger exponent there. And then again, 450 divided by 150, math enter works, but when you do it, you're going to find out you don't need that. 450 divided by 150 is 3. Where's the 3 go? On top, because 450 is bigger. Okay? And that's all the further I can get. Because again, x and y aren't the same base, so I can't subtract their exponents at all. So it is. It's just a process that you're working through as you go with these. Now, I'm not quite sure why we don't have this parenthesized. We're going to take care of that here. Okay, now this time, good question. Do I multiply across again? Not this time, because now that I've got pluses and minuses, that would make this really complicated and complex. So what I want to do is I want to work my way through, and I want to say, okay, can I factor any of this stuff? Can I simplify it at all? Well, x minus 3 I can't do much with. What about 2x minus 8? Yeah, we can factor that. We can take out a 2. So again, whatever I'd multiply 2 by to get each of these back is what I would put down in the denominator. Ooh, now this next one, now we're going to see if some of you are on your toes. 6x squared minus 96. Do they have anything in common? Divisible by 6. Okay, you're like, okay, what's the big deal with that? To get to negative 96, yeah, it's got to be negative 16. Yep, negative 96 divided by 6 is negative 16.
So that's what he has up there.
Well, I would think I'm having a thing here because okay, I get it.
Now, what may be floating around right now, though, is you're kind of looking at what are in the parentheses. And you're going, hey, that kind of looks familiar. It's perfect squares. So not only could I take out the 6, now that it's out of there, I can factor what's left in there. Because I can square x to get x squared. I can square 4 to get 16, and again, plus and minus. Now that just gets rid of the parentheses part. It doesn't get rid of the 6. Don't get rid of the 6. But that is kind of a nice setup for the last part that we're factoring, because it's another difference of squares. X and plus minus what? 3. Okay. So now, before I go multiplying across or doing anything else crazy, yeah, look for the exact same common factors that you see. And again, I can cancel top to bottom. I can cross cancel. The only thing I can't do is cancel horizontally, sideways.
Can you cancel whole numbers, like 6 and 2?
I can right now if I want to. If I want to look at this, because the question was just asked, can I mess with the 6 and the 2? I can, but I'm going to kind of blend that into my last step here. So like, I see the x plus 4 that's still left up top. There you go. I see the x plus 3 that's left at the bottom. But before I just write the 6 and the 2, I go, hey, 6 divided by 2 is 3. Bigger one's up top. I'm ready to roll. So again, it's not that this stuff is terribly hard, but you do have to take the time to concentrate and think about. Now 4, now it's been a while since we played with this. We'll come back to this part in just a second. Let's deal with this first. Okay, difference of squares, x plus 5, x minus 5. And I can't do anything with the x plus 1. Maybe that's what Mrs. Abruzzo was trying to be nice with. She's like, if it's not factorable, I won't put it in parentheses. Sneaky, sneaky. Okay. Oh, excuse me. Thank you. And then what about my denominator? Minus 1 and plus 1, because that's what I square to get 1. So let's go back to 4 for a second. This is a little crazier. Because here's what I've got to remind myself of with this one. When we have 4 terms, we're going to pair them off. Okay, and I'm going to do a little side work here. You should have some room left up here on yours, but I'm just going to use a Post-it note so it's right next to it here. So now I'm going to look at these 2 terms. I'm going to say, okay, what do these 2 terms have in common? Okay, x squared. Okay, so if I take out x squared, what do I have left? X plus 5. And then I do that one more time for my other set of parentheses. You're like, well, wait a minute, though. X and 5, there's like nothing in common. Okay, let's take, when there's nothing else in common, I can always take a 1 out of there. And since they both have a negative, okay, let's take a negative 1 out. Because if you remember back to when we were doing these a lot with factoring, X and then plus 5, because negative 1 times 5 is negative 5, I should get the same set of parentheses at the end. And if I have, that's a good thing. Because now when I go to write my answer, okay, that common set of parentheses gets written only once. I don't put it twice. And let's kind of look at this for a minute. Like X plus 5, and then I put down all the other stuff that's outside. Hey, I just saw that. So it factors the same way. Okay, so I just take it in little pieces as I'm doing this. And again, sometimes that can be tricky because you do all the work to get this done to get to here, and you're like, whew, I finally made it. They're like, dang, I got to factor this part again because it's a perfect square. But that happens. But here's the kind of fun part. I get to go cancel crazy here. I got X plus 5s. I got X plus 1. Okay, I can cancel these. I couldn't cancel sideways. Okay, just a reminder. Yeah, and I can cancel the X minus 1s. So you wipe all that stuff out. Let's see what we got left here. X plus 1, X minus 5. They are not the same parentheses. That's as good as it's going to get. Ooh, that one was kind of crazy. But again, taking your time, using your help sheet to kind of guide you along is going to be the way that you want to do that. Yeah. This one? It's still here. It's right here. Because when I'm going to do the factoring, the common factor, whatever I have in the parentheses, is part of my answer. And then the parts that I took out of each of them become my other set of parentheses when I'm factoring those. And then to get from here to here, I noticed, hey, that's a difference of squares. So that's how I got all 3 of those sets of parentheses as I was going through. Yeah?
I noticed that you got like 3 sets of X plus 1 there. How do you know like to go from side to side or to cancel out?
Okay, it's always when we're canceling. That's a good question. And how do I know where I can cancel? Again, I can cancel diagonally. I can cancel up, down. Like if I would have canceled these, I could have done that. But then that one wouldn't have canceled out because it's 1 for 1. I can't say, well, I see 3 of them, I'm just going to cancel all 3. It doesn't work that way. You always have to have one to cancel out another one.
All right.
But yeah,
So
it's...
would it matter which one you would cancel?
Nope.
So you could cancel side to side?
No, not side to side. I can't, like, if this one wouldn't have been here, if this X plus 1 wouldn't have been here, could I have canceled out these X plus 1s? No. I can't do side to side. I can...
Both of them would have been in your answer.
Yes. I can cross cancel. I can cancel top to bottom in a fraction. Those are okay. But yeah, the only one that's against the rules is sideways. Can't do sideways.
All right. So you would still have gotten the same answer then?
Yes. I just would have had this X plus 1 left over to stick up here instead of that one.
All right, just making sure.
Yep, absolutely. Always good to ask questions. Always good. That's why I like having you guys do the video stuff with me, because you guys do ask questions, which I appreciate. Okay. Let's keep factoring away here. Okay, yes, we are going to be flipping it. Looks like a diamond to me. Yep. So, I need 2 numbers. Nice. That multiply to 48 and add up to 14. Now, here's my clues that I know, though. Since it's positive, I know they're both the same sign. Both positive or both negative. Both have to be negative. And Rena nailed it with that. Again. Multiply to 48, add up to 14. 12. Wait. No. No, 12 and 2 doesn't get me to 48, though.
Oh, 20. No.
We're still pondering. 8 and 6. Okay. So that's something to be careful of, because you're like, well, 12 and 2, they take care of the one part, but if they don't take care of both kind of gets me in trouble. I'm going to write this up here a little bit because my whiteout's not quite ready yet. I got a little too excited on answers here. What about in the denominator? I can take an x out. Okay, it's not a difference of squares. I can get an x out, though. So as I move along, so I'm like, man, I'm rolling on my factoring. It was already mentioned, since this is a division problem, these two guys get flipped. In other words, it looks like this now. So, and it becomes a multiply problem then, which we've been dealing with already. Well, I can't do much with 6x, because there's no pluses or minuses. But what about my denominator?
You could take a 3 out.
To take a 3 out, and that leaves me with x minus 8. And again, now at this point, once everything is factored, now I can start canceling away with different things. So I'm like, okay, so the x minus 6, the x minus 8, the x's that are individual, that aren't bonded, nice. And you're like, 6 divided by 3, that's all I got left. You're like, all of that? I just get down to 2? Yeah.
How to cancel the x? Like the x.
Okay, let's say I hadn't canceled the x's out here when I was going. If I'd have multiplied across, I'd have had 6x over x times 3, which is 3x. So when I got to that step, then I'd have canceled out the x's anyway and been left with 6 over 3, which is 2. So if you don't see the x's right away, when you do go to make that final fraction, you will see it. It's just a matter of making sure that we kind of take our time and don't lose anything. Good questions. Oh, check this out. Okay. Piece by piece, we'll tackle this sucker. All right. Looking like an old-fashioned diamond with lots of pluses. It is all positive. 10 and 2. Nicely done. Denominator. Yes. Again, hopefully some of you are starting to see this difference of squares thing like is a nightmare or a dream or something, because I'm putting lots of them in here. So 2x times 2x is 4x squared. 3 times 3 is 9. Plus and minus. Nice. Okay, so I get to the next part. I'm like, oh, divide. These guys are getting flipped. So I'm going to do this one first, because this is my numerator now. So what do those two guys have in common? 3x squared, because I have to take the smallest one I see, and squared is as small as it gets. Times 2x, because 3 times 2 is 6. 2 and 1 is minus 3. Okay, rolling. There's my new denominator. X squared. X squared and x is x to the third. X squared times 10 is 10x squared. And then remember, this last one, like the last one's not even a fraction. I can always make it a fraction by just putting it over 1, because I want to remind myself that that 2x plus 3 is up top. It's in the numerator. Hey. There's a whole bunch of stuff that's going to get canceled here. Whack, whack. Whack, whack. Whack, whack. X squareds. And even if you didn't see those right away, because we had that issue with the last one, some of you are like, wait a minute, what happened there? Let's say all you canceled were parentheses, and you're like, okay, what have I got left? You're like 3x squared x plus 2 over x squared. But you're right. Hopefully you'd get to this point and you'd say, hey, the x squareds, they can go away too. I wouldn't, because if you do that, and the question is, if you couldn't hear it, could I just distribute the 3x squared through? Well, there's two issues you're going to have with that. One, once you do that, you're not going to see anything that cancels anymore.
No, like where it's x plus 2 and then well, you say you cancel out the x squared, so would it just be 3?
Yes, and now if you wanted to distribute the 3 through and call it 3x plus 6, sure.
That's what I thought.
Oh, I'm sorry. Yes, at the very end, if you want to do that, you don't have to, but you could. I thought you meant doing it this step back here, and I was like, I don't think I'd do that. Normally, once I factor something, I'm not going to redistribute it back out, because I'm not going to need that. Nice. All right, so again, that's our multiply and divide. So then we go a little further. We say, okay, now we're doing adding and subtracting. Now we need a common denominator. This one already has one. Now again, notice that says minus in the middle. It does not say times. Do not multiply them. Write what's there. But before you circle it, now think about this for a minute. Am I really that nice? Then I would give you a problem where you're just going to write it, put it straight across and circle it? I don't think so. Yeah, we've got to take the common factor out, which here would be 6. Largest number divides into both, and x. And you're never going to guess what's going to end up in the parentheses. X minus 2. What's a coincidence? Now, since I'm at one fraction and I'm simplified, now I can cancel those out. Until you are completely simplified from 2 fractions to 1, you cannot cancel. Don't cancel until the end. All these little things to keep an eye out for. So I keep kind of working along here. And I'm like, okay. Again, I'm going to mentally go through the checklist again. You have your sheet to help you with this, the one that's, I think, green. When I'm finding my common denominator here, this x is free. It is not bonded. This one is. They are different. So when you're going to make your common denominator, okay, any coefficients, the 3 gets to be part. Any single variable terms, that gets to be part. And any sets of parentheses, any quantities, get to be part. Okay, so I need all of it. And of course, whatever's up there already. Now, again, I become a builder now, a puzzle solver. Whatever I need to multiply to get from here to here, okay, whatever I have, I can check off. Whatever piece is missing or that I don't have yet, or that I would need to multiply, needs to go up in the numerator, because otherwise I change the value of my problem, and I don't want to do that. And I'm going to do that in the second one as well. Hey, I'm glad somebody said that. Don't get rid of the bottom. These aren't equations. Okay? When we get to the equations on the back, then yes, I can at that point. But when we're just simplifying,
Don't you have to distribute?
we're going to distribute. So 4x plus 24 plus 6x. Over all my stuff here. Find my like terms, my 4x and my 6x, which is 10x plus 24. Okay. After all that other stuff we've done, at this point, this would be where I could start looking to see if I could cancel something. Which I can't, I don't think. But let me take one more peek at that numerator. Is there anything else I could do to factor the numerator at all? Do they have anything in common?
Yes.
Okay, I could divide them both by, not by 3. 3 won't go into 10.
Oh, 2.
2. And we've had this discussion, and if you've been watching these or here or listening at all, I've probably said this, I don't know, a half dozen times at this point. You're like, again, why would I factor something out, Harty? Nothing's canceling. 2 doesn't go into 3. Those are both bonded. Why would I even do this? Because the time that you don't is going to be the time it actually produces. So do it anyway. Now, if you circled that as your answer, would it be right still? Yeah, because nothing canceled this time. But that's not guaranteed going to happen every time. If you get this part down, okay, you're going to get a majority of the points, and that's what we're shooting for on this. Sometimes a detail is going to slip us by. It happens. It happens to me. But I've got to watch out for that stuff. Okay, let's crank it up a little here. Are either of my denominators factorable? Yeah, this one is. What's that going to look like? X minus 2. Why is it important to factor? Because now my denominator is not going to be huge, and then I'm probably still going to miss it. Because now I look and I go, okay, I got a single variable, x. I have a set of parentheses, x minus 2, but don't do squared. It's the biggest exponent I see in one fraction. I don't see 2x minus 2 as in a fraction. I only see 1. So, take this. I'm like, okay, I'm ready to roll. Old to new. Ooh, I got everything. I got the x. I got the the x minus 2, excuse me. Second one, it's just going to be x squared because I need another x. Okay, because I got the x minus 2 part. So what do we got here? We got 5 plus x squared. Not factorable. Not the same set of parentheses. So sometimes I don't have to do anything else. That'll happen. It's possible.
And you got x squared because it was just a single x there, right?
Right, because it ended up being x times x.
So it was a number there, you multiply by 1, but there's a letter there, you just square it.
Run that by me one more time.
So if there's like a number there, like the 5, you just multiply by 1, but if there's like a letter there, you square it.
The only reason I did a 1 here was because I already had the x and the x minus 2 there already.
Yeah. But since like it was both the same for both sides, I'm just curious, since there was an x there, you didn't multiply by 1, you just instead of multiply by another x.
Right, I multiplied by another x because I had the x minus 2 in my old denominator, but I didn't have another x there like I did in this one. So I had this piece, but I didn't check off that. That's why I needed to have one up there.
Oh.
That's the only reason I needed to have one up there. Okay?
So still the original thing, okay.
Yeah.
Now if that x wasn't there, you would technically multiply by 1, I think.
Yes.
Okay.
Yes.
All right, okay, that was my
Yeah, if I have everything, I'm still going to just multiply by the 1. But again, that's why we do these, is to make sure that we've got everybody in good shape. So I look at this one. Again, factoring helps me because it lets me see I already had a common factor going. So I look and I'm like, well, I don't have anything outside of parentheses anymore. Okay. So my LCD ends up being the x minus 9 and the x plus 4, because those are the different quantities, the different sets of parentheses that I see. So I get that set. And then again, it's all about going into builder mode. Got the x minus 9, got the x plus 4. If I have everything, I usually will just put a 1 in, because I always like to put something. On the second one, I've got the x plus 4. I need the x minus 9, and I'm going to have a room issue, ain't I? Oh, well, that just happens sometimes. So, okay. For my room purposes, I'm gonna start going up this way a little bit. So I notice when I go over here, that'll just be 18x. This will be 2x squared minus 18x. So, yeah, 2x squared, 18x minus 18x cancels. That's all that's going to be left up in the numerator, which is lucky for me because I didn't have much room to write anything else. And I'm set. Again, I can't cancel the x squared because everything else is in parentheses, kind of stuck. But that's what I'm going to be on the lookout for. That's what I'm going to be looking for with those. Okay. We're surviving here. We're surviving. Okay, to the back. Oh, another nice one. Already have a common denominator. Don't get cute. Another one where you must ask yourself, is Harty really this nice? Nah, not really. So, what do those two have in common? 4x. So, x times x is x squared plus 6. Again, it's at this point that I can cancel stuff. Don't do it before then. Wouldn't be a good idea. And I just keep working those through. All right. 12. Factorable denominators. There you go, people. Difference of squares. With one additional little issue this time to play with. And the crew that I already had take a test on this had some issues with it, so we're going to really buckle down on this to make sure you guys don't. Okay, so I get my common denominator. 2x plus 1, 2x minus 1. First one, check, 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 check. Okay, we're all good. Second one, right. 2x minus 1. But here's what I want you to really think about. There's a minus in the middle. That minus means when I distribute the 2, I'm distributing the negative with it. So suggestion, put the negative with the 2 so you don't forget about it. So this becomes negative 4x plus 2. And again, notice I'm not canceling anything at this point. Can't cancel those. That would make life bad. I wouldn't have a common denominator anymore. 5 minus 4 is 1. So 1x plus 2. Nothing I can do with that. No parentheses are the same. Woo, I'm done. Like, okay. Kind of see where he's going with some of this stuff. 13. Different question. Consider the equation. What is or are the excluded values? What doesn't work? What makes the denominator equal 0? That's the problem. So I don't care about what's going on up here. I just want to make sure that whatever's in the denominator never is going to equal 0. So, what can I add to 7 that would give me 0? Negative 7. Okay, so negative 7, that's a bad idea. Yeah, I already did that here. What minus 7 equals 0? 7. Those are the two excluded values. Those are two values that would cause me a problem. You don't have to solve the whole thing. Just set the denominator equals 0 and go about your business. Not bad, not bad, not bad. All right, so now, those are my cancelers out there. Because we talked earlier on the problems, we want to get rid of the denominator. These are the ones upcoming that you can. Once you see an equals, we use the common denominator to build our fractions, then we get rid of it. So, question. What's my common denominator? 2x, x plus 1. I got the coefficient. I've got the individual variable. And I do it just like I am when I was building those fractions up when I was adding and subtracting in the last section. So I'm like, all I get to check off is the x. So I still need the 2 and the x plus 1 there. Here, I check off the 2 and the x. I still need the x plus 1. And then over here, I can check off the x plus 1. And in retrospect, I needed to make this about a 3-sheet review. There you go. Got it on tape. So, numerators have been built. It's an equation. Now I can get that out of here. So I look to see what I got. Well, 7 times 2 is 14. So 14 is what I get to distribute through. I'm going to try to write a little smaller here. Over here, if I'm looking around, I notice 3x times 2x is 6x squared. And if I distribute my 6 through, so that's a lot of 6s. 6x squared plus 6x plus 6. You're like, okay, so now what? If I have a squared term, I need to try to get all of my terms to that side, because we're probably going to have to factor this. So I'm going to minus the 14x, and I'm going to minus the 14. So minus the 14x, minus the 14. And I'm going to have to take a minute to go ahead and see if I can factor this. Now, some of you may go to slide and divide right away. Some of you may notice there's a common factor. It all depends on how you want to do it. But I know most of you how you think. Most of you think, oh, I'm going to slide and divide right away. Okay. So if that's it, let's see if that works. Because you never know until you actually give it a go. And I will be of some assistance here. Yes, this is factorable. They're like, are you sure, Harty? So a negative here means it's one of each. So two numbers that multiply to 48 that are 8 apart. 12 and 4. But again, don't forget about that number at the beginning. So Harty's swinging up here. Now, before you sit there and go, well, 4 out of 6, you know, that just gets me a fraction. I'm just going to put 4. I'm going to put 6 in front. Don't you dare. You're like, but it didn't come out nice. But if I do math enter, ooh. So x plus 2/3, x minus 2. Now that I've reduced the fraction, and I can go through and get my answers. So I'd take each of those sets of parentheses, set them equal to 0, and I'm just going to do that part for you because I want to make sure we get a chance to get to the other problems. And I make sure that it doesn't cause a problem in my denominator. But 14, 0 would cause a problem. -1 would cause a problem, but neither of my answers are that. So I don't have to do that. And I'm just going to get that set that way. Now, I'm going to skip around a little bit for a second. I'm going to go down to the last two, and then I'm going to come back up, because I want to make sure if I run a little low on time that we've hit everything here. So, down to 31 here we go. So working alone, John can paint a fence in 6 hours. So remember, when we're back looking at these, individuals, we put at 1 over that number. Deshaun can paint the same fence in 7 hours. So again, individual, how long would it take if they worked together? 2 individuals on the left, together on the right. I'm going to multiply my denominators together. And remember, it's like distributing that 42 all the way through. So 42 is on top. So 42 divided by 6 would be 7t. 42 on top divided by 7 would be 6t. And 42t on top, just the t's would cancel and leave me with 42. So I go ahead and I'm going to get funky numbers. That's okay. It's like 3.23, which is sensible because they're working together. It should take less time. And that's how these set up. Now, if they tell me the together number, I just put that over here and I work it that way. I'm going to give a little bit of advice. On 16, do exactly what it looks like you should do. This is the part I'm going to do. I'm not going to go crazy with this. Cross multiply, distribute, and work that out. Okay. That's a little more straightforward. And then I'll just get the setup on 15, and then we should be pretty well in shape here. So I get to here, factor my denominator, which actually is my denominator. Oops, I almost lost one there. And I'm going to have to get back on the screen. So as I set these up, first one I got everything. So that was good. Second one, I've got the x minus 3. I need the x plus 3. And the last one's a little more complicated because I need both. But once I get that set up, multiply it through, you're going to have an x squared term, get all your terms to the x squared side and go. So some of you are packing up. I'm just going to clean this up. And multiply it out. And actually let you see that this one works out pretty slick, except the 3 causes a problem. And that'll be my only answer. So again, be ready to roll tomorrow. Just take your time, have your help sheets, and things should go